Hello everyone, welcome to this video. In this video, we'll be talking up and seeing this question. Here, the question I pose is this notation AH, right? Where we for some group G we have some subgroup H, and from the subgroup we are taking, in fact from this group G we are taking some element A, right? Now for this structure, this bar, and within the bar we have AH written with us. Does it represent the number of elements which are present in the coset? Remember, you can form AH as the coset. So whatever is the coset, if you take this represents order of elements in the coset AH, or it is the order of the element AH which is present in the quotient group. Remember, for a quotient group we have its element as coset. So what is it? So it would depend upon the context that we are studying, right? For example, if we I give you an example where we represent both the instances of this mod AH. What does it represent in different cases? So let's see an example where we take our group to be Z18, addition modulo 18 group of integers, right? So it contains the element 0, 1, 2, 3 up to 17, and the group operation is addition modulo 18, correct? So here we take H to be a subgroup of it, and we define it to be like this, that it is generated by the member 6. So that means it would just have the multiples of 6 here. It would be 0, 6, 12 and 18. If you take 18, and when you calculate its mod 18, you will have it as equal to 0, which is again this member. So whichever member you take, you have only these as the numbers, distinct elements present in H. Now let's first of all see what all cosets could be generated using the subgroup in Z8. So for that, what we do, we take different elements of it, we add it to H, and we see up to how much? 17 plus H, and we see how many of them are distinct. So you see only 6 distinct cosets we have with us. These are this. Why? Because if you take any other apart from this, you will end up getting these back, right? So 0 plus H is obtained when you add 0 to these elements. 1 plus H is obtained when you add 1 to these elements. 2 plus H is obtained when you add 2 to it, and so on, right? And similarly, if you wanted to construct 7 plus H, so what would it be? 0 plus 7, which is 7. 6 plus 7, which is 13. And then 12 plus 7, which is 19. So you see, when you take its mod 6, so it would just be 1. It would just be how much? It should be 7, right? And it should be 13. So you see, when you take, you can write, because you can write it like this, 7 could be written as 1 plus 6, right? 13 could be written as 7 plus 6, and then 19 could be written as 13 plus 6. So this is 6 and 6 and 6 would be cancelled. So you're left with only 1, 7 and 13, which is what? Which is your 1 plus H. So you end up getting the same coset, right? So these are the only possible distinct cosets of H in Z18, right? Once you know this, now using this cosets, we can construct a factor group out of it, and we call it by Z18 oblique H. So it would contain all these cosets 1, 2, 3, 4, 5 and 6, right? As I have listed here. Now, as I've told you, what would be how would you form the operation in this quotient group? If you take two elements, suppose we take 3 plus H and 4 plus H, then how would you add them? You will add them simply by adding the numbers 5 and 4, which is 9. Again, you can write 9 as 3 plus 6. Now 3 would be absorbed by H, because H is generated by 6, right? Therefore, you will be left with 3 plus H here, correct? This is how we perform the addition operation within this factor group. Now, what is the meaning of notation? The actual representation and the actual question for this video. So here you see, we can use different notations for this 3 plus H. Now we are taking this member 3 plus H out of these so many. You are taking 3 plus H. Now in the first case, what is your 3 plus H? It is a coset which consists of 3 members, 3, 9 and 15, right? This coset is this. Now what would be the order here? Now because this is a coset, it is a set, it consists of 3 members, so its order would be 3 because it contains 3 numbers. So here it represents the number of element it has, right? In the second case, if you take 3 plus h to be the member of the quotient group, right? If you take this as a member of the quotient group, in that case this mod 3 plus h would represent the order here. So that means how many times you have to add it so that you get back to the identity, which is 0 plus h here. So you have to do it 2 times here, so therefore the order here is 2. So you see the context, how it differs in different, when you take it as coset, it comes out to be 3, and when you take it to be a member of the quotient group, it comes out to be equal to 2. Hence this notation mod ah represents the number of elements in coset in some cases and the order of the element in quotient group in other cases. So I hope you understood this question well. Well, that is it for this video. Thank you for watching.